All right, so on the left side, let's start with things that we know. We said oxygen was going to be a -2. What does that make nickel in this side? +4. What about cadmium on this side? Remember, it's in its elemental form, so it must be a 0. On the right side, cadmium is attached to 2 hydroxide ions, which have what collective charge? -1. Since there are 2 of them, what does that make the cadmium on the right side? +2. What about the nickel? Same situation. +2. When we're looking for oxidation and reduction, remember we compare the same 2 things. In this particular case, we're going to look at cadmium and nickel. Cadmium goes from a 0 to a +2. Did it gain or lose electrons? It lost 2 electrons specifically. So was it oxidized or reduced? Oxidation is a loss. Reduction is a gain of electrons. All right, for the nickel, we went from a +4 to a +2, so what happened? It gained 2 electrons. In gaining 2 electrons, it was reduced. All right, so we would say that cadmium was oxidized. We would say nickel was reduced. Because cadmium was oxidized, it was the reducing agent. Because nickel was reduced, it was the oxidizing agent. Remember, those are invertly related. All right, example 20.2 is to balance an equation in acidic solution. You're going to want your steps if you don't already have them. Get them out next to you. This one's an acidic solution, so we're going to follow the steps as we did yesterday when we were working on our practice problem in class. Then we will balance one in basic solution, and we'll have to add a step. All right. First thing I'm going to do is copy it down. All right, what is our first step for balancing our half reactions?
Oxidation numbers.
Oxidation numbers. So let's start there. What do we know about oxygen? Always a -2. There are 7 of them, and the overall charge has to be -2. So whatever our chromium ends up being, this is the equation we're essentially solving, right? 2 of our chromiums plus 7 of our oxygens have to equal a total charge of -2. You see that? Yes, ma'am. Sorry. I don't know. I can't do that math in my head. Cool. For those of you that can't do it in your head, chromium is going to be a +6. What's our chlorine going to be? We will, when we separate them, we will balance atoms. We're not there yet. Yes? -1. -1. It's given as -1, right? If it's given, that's what it is. What about over here? What about here? 0. This is a neutral form of this particular element. Okay, what is oxidized? What is reduced? Let's do that next. Did it gain electrons or lose electrons to become less positive? It gained electrons. So this was the reduced thing, which means chlorine must then be the oxidized thing. Okay? What's our next step? Not yet.
Write the oxidation and reduction half reaction.
So we have to split the two reactions, right? Remember that if they have atoms in common, they go together. So one of my reactions is going to have the chromium atoms. The other of my reaction is going to have the chlorine atoms. And now I have two reactions to work with. All right, which one do we want to balance first? The one on the left or the one on the right? Let's do this one first. Okay. We are in step 3 of our balancing process, and it says to start by balancing atoms that are not oxygen or hydrogen, which means chlorine. Next thing to do is to add water in order to balance oxygens. Do we need to do that here? No, we do not. So we don't need to then add hydrogens to balance out the hydrogens that we would have added for more water. We skip all the way to the bottom of that when we balance charges by adding electrons to one or the other side. On the left side, what is our current total charge? On the right side, it's 0. So we need to add 2 electrons to the right side. And that one is now balanced on its own. Not so with this guy, right? First thing to do is to balance the non-oxygen atoms. So I'm going to put a 2 in front of my chromium. What's the next thing to do?
Water.
Add waters. How many waters do I have to add to the right side?
7.
Thank you. What do we do next? Add hydrogens to the left side. Remember that they are positively charged. So we're going to add 14 hydrogen positives. Here's where I'm at. Are the atoms now balanced? Do I have the right number of hydrogens on both sides? Do I have the right number of oxygen on both sides? Do I have the right number of chromiums on both sides? The answer is yes. Next thing to do is charge balance. So on the left side, my total charge is what?
12.
Correct. So this whole side is a positive 12. The left or the right side has a what charge?
6.
Positive 6. And the only thing we can add at this point are electrons, right? So are we going to add electrons to the left or the right to balance this charge? To the left. How many?
6.
6. Yes.
So do you look at the charge for the?
I look at the total charge, including coefficients.
Of which ion?
Anything. So for instance, over here I had 14 H pluses, so that's a 14 plus charge.
Oh, and then
This is only 1, negative 2, so 14
Okay.
minus 2 is negative 2, or positive 12, right?
Yeah.
Over here I have 2, 3 plus charges, so that's a positive 6.
Okay.
All right, so next thing to do is to add our 6 electrons to the left side. Write it out again. That's my balanced half reaction for that chromium compound. What next? Nope.
Multiply usually.
We want to multiply to get our electrons in both reactions to be the same number. So in my one reaction I have 6, and the other I have 2. So I can just multiply that other reaction by 3 to get it up to 6. Right? So we're going to multiply this guy by 3. Now what do I do? Put it all together. You can do that without me. Make sure everything on the left of both equations stays on the left of your final equation. Everything on the right stays on the right. So put the two reactions back together. Yes, ma'am.
Why are the electrons for the side, so for the left side, they're on the reactant side, but for the right side, they're on the product side?
Correct.
Why is that?
That was so that we that's how we balanced our charges, right? This is the react. So in order to get them back together, that's exactly what we want to happen, Shelby. Because when we balance this guy, charge balancing this particular type of reaction should put electrons on the reactant side. Charge balancing this particular type of reaction, aka an oxidation reaction, puts the electrons on the opposite side.
So when you add electrons, you're basically
The only reason we added electrons to either one was to balance the charges, right? Pay attention to that when you're doing your half reaction methods. That's weird, but when we separated the two, we treated them individually, right? And the reason we added 6 electrons to this one was because this side had 12 plus, this side had 6 plus, right? So we were balancing the charges when we did it. The way this ended up, in your final reaction, the electrons should cancel because they'll be present on either side. Your final oxidation reduction reaction, after you add them both together, should have no electrons in it. Yes?
Are the hydrogens and the water going to cancel?
No?
No? Leave those?
Yep.
Is that only when it's OH?
That's only when it's, no, that's only when it's in an acidic solution. In an acidic solution, we can have protons, the H pluses. In a basic solution, we'll have OHs instead. And we'll do that one next. Yes.
So, would it, would,
That's what we did yesterday.
Yeah.
would you ever have, would you ever have,
It's 2, so that's why you multiply.
or would you ever have, electrons on either, or on both sides of one reaction?
We make it so that the electrons will cancel out on either side. And no, the definition of an oxidation reaction puts the electrons on the right. A reduction reaction puts the electrons on the left. That's the reduction oxidation paired together. Yes, ma'am.
I'm sorry I said this, but why
Sure.
do you times it by 3?
Because we want the number of electrons in each reaction to be the same number, so that when we add them together, they cancel on both sides.
Oh, okay.
Do you see?
Yeah.
Okay. It's a good question. Any other questions? So what's our final reaction? It's a lot, right?
All of the stuff on the
How about this? Does your final reaction have electrons in it?
No.
It should not, because they should cancel.
Oh, I don't remember that at all.
Left side, oh, left side.
Yeah.
That should be the final reaction you have written down after you've canceled out your electrons, correct?
Yeah.
You have to forget something? Good. Thank you. All right, let's do it again. This time we're going to do it in basic solution. So after we add the hydrogens to one side, the next thing we have to do is add the same number of hydrogens we added in hydroxide ions. Okay? An acidic solution should have protons. That's what these are. A basic solution should have OHs. That is how you know if you've balanced it correctly. If your final answer has hydrogens in it and it was a basic solution, you skipped a step. Yes?
What if we have neutral solutions?
We wouldn't balance them in a neutral solution. They're always going to be one or the other, for the most part.
The next one really wants to be basic. Acidic dye. Right.
All right, let's start by getting it written out. Determining our oxidation states. You can do that part without me.
Mutate probably.
I mean, it's up to you. I don't know how much the last one took you. Depends on how big you
A
are.
good half a page.
Make sure you have it written down somewhere because you're doing it on your own next. Minus.
Do we need to know the states for these reactions specifically?
Not necessarily. The states only help if you have something that's like elemental. but we don't have anything elemental in this one.
I'll keep writing.
I see one place that everyone's going to get tripped up at for our oxidation numbers, and it's the nitrogen in CN. That nitrogen, since it's the most electronegative of the two atoms, is the one that's negative, and it gets its predicted charge of -3 in that one. It should also have that predicted charge on the right.
Can you say that again?
Yeah. Nitrogen is going to be the one in this species that gets a -3 charge because it's the most electronegative. So it behaves as the non-metal. Carbon, in this case, acts as the metal to balance it out.
Yeah, I thought that was fine. I got it.
Assuming none of us would you give us that information?
I would likely tell you that carbon and manganese are the two that you need to focus on, and that those are the ones that should change charge, but I may not necessarily say that nitrogen is a -3. Does that make sense?
Why is carbon a -3?
No, not carbon, nitrogen. These are for nitrogen and oxygen. Carbon is the one that has a charge that changes on both sides. What do we get carbon to be on the left? Should be +2. In order to make an overall charge of -1, with nitrogen being -3, carbon has to be the one that has +2, right? Yes, ma'am.
For the CNO,
Yeah.
on the actual thing, it doesn't have any numbers. Is it supposed to?
Doesn't have any numbers.
It
What do you
doesn't
mean?
have any on the bottom because you put ones up there.
Oh, those are oxidation numbers. Are you talking about these?
Oh no, the ones that were under it, the one that you just erased.
Oh, that wasn't a number. That was just an arrow. I was trying to indicate that the -2 goes to the oxygen.
Okay,
Sorry.
It's like a 5. And
It should be a C. It should be one of each in this particular thing. What's the manganese over here?
+8.
Oh, it's a 4.
I got +7.
I think it's a +7 because it's a -1 charge overall. -2 times 4 is -8, so this should be +7. All right, on the right, let's look at the carbon. Overall charge is a -1. So what does that carbon have to be? +4. What about the manganese over here? +4. Okay. We're looking at the things that change charge, right? To figure out what's oxidized and what's reduced. So my carbon and my manganese are the two that change charge. What happened to my carbon? Did it gain or lose? Did it lose electrons or gain electrons? Remember, it lost electrons. When it becomes more positive, it means it gave up negative charges, which means it was
I
oxidized.
said lost, or I said gained, but I wrote.
Oh, IL. It's okay. All right, manganese went from +7 to +4. Did it gain or lose electrons? It gained electrons. If you're confident on one of them, the other one has to be the opposite. All right.
So does the CN all stick together then?
Yes. So the CN on the left and the CN on the right is going to be one of your half reactions. And the other is going to be the one that has the manganese. What's next?
Balance it out.
Balance anything that is not not oxygen or hydrogen.
Oh, so we don't have to balance the oxygen.
Not the oxygens yet.
We don't have to balance it.
Oh, okay.
So
No
the
wonder
first
why.
one's already balanced. Starting for A.
So do we have to do anything over here? No. Do we have to do anything here? No. What do we got to do next?
Can we add the
Oxygens, guys. You got to balance your oxygens by adding water. So over here, what happens? We're going to add an H2O to this side. To balance the only way to balance oxygens is to add water right now. So we're going to add 1 water on this side to balance the oxygen.
And we need 2 hydrogen.
And then we add an H.
Right? Okay. Then what are we going to do? We're going to add 2 H's to this side to balance the hydrogen that we just added. All right, here's the additional step because we're in basic solution. Since we added 2 H pluses and we do not want to have protons present in our basic solution, we have to add hydroxides on either side to get those hydrogens to become waters. So how many hydroxide groups do we need to add to make enough water to get rid of those protons? 2. So we're going to add 2 OH minus to this side, but since we added it to this side, what we got to do over here? Got to add it to this side. Don't be rude.
I'm not.
Mm-hmm.
I was really excited about it. So I finally got
Here we are. What can I do before I move any further with that H plus and OH minus? Can make it water, right? So instead of writing this, we can write that guy.
Why would it be 4? Why is it 2?
Because that's just how you do it, Carly.
Thank you. Oh, duh. Okay, yeah.
It's okay. All right. Next up.
Cancel out the waters.
We could cancel out the waters. I'm going to have you save that just for a minute because our next step would typically be to balance charges, right? So why don't we balance charges first? I got 2 negatives from this one plus 1 negative. So this total side is 3 minus. What do I have over here? Minus 1.
Don't keep track of it.
We will. We will.
Well, like, not like right now.
We don't have to do it right now because we still have to balance the other reaction. And when we put everything back together, we're going to see waters everywhere. Water, water everywhere. All right? What do we need to do to balance the charges?
We're going to add 2 electrons.
To which side?
To the right side.
To the right side. And now is it balanced as far as we know?
Yeah.
If we do not subtract any waters, we're fine, right? Like we're good right now. Okay? All right, let's circle that one. Save it for later. Next up is our manganese. I'm going to try to move it up so that I have space. All right, what do you want to start with?
Water.
Where?
Right.
How many?
2.
To balance the oxygen on the left, we have to add 2 to the right by adding water. What's next? Balance the hydrogens. So how many hydrogens did I add to the right?
4.
So how many do I have to add here?
4.
Remember, we're in basic solution, so we cannot have protons. So what do we have to add to get rid of those protons? OHs. How many should we add?
4.
The same number as what we have. And we're going to do that to both sides. These guys are going to make how many waters?
4.
Thank you.
Not 8. Duh. This is how you do it.
All right. I didn't say that's just how you do it. I showed you why.
She said that.
All right.
That's just my reasoning.
Here we are. What should we do next? Why don't we balance charges next? Because that's what we have left. On the left, what is my total charge? Do you see the -1 and only the -1?
Yeah.
On the right, what is my total charge? -4. You have 4 OH minuses, which means -4. All right, how do we balance the charges? We've got to add 3 electrons to the left.
Yes.
Here on out, we follow all of the rules we followed before to get them back together. And there is my total balanced equation.
2 boards later. Is there a
I've only used one board. What are you talking about? What's up?
specific reason why the electrons aren't like on the they go
They go wherever you can fit them.
Why do we have?
You can put them on the front. Doesn't matter. Yeah, they're going to go away once you get them back together.
Oh, okay, never mind, then I'm listening.
Okay, okay. All right, so what's our next step before we add them back together?
Multiply.
Our electrons have to be equal in both reactions, right? So what can we multiply to get 2? What's our goal? 6 electrons. Do you see why? If we multiply this one times 3, we're going to get 6 electrons. If we multiply this whole one by 2, we're going to get 6 electrons. We want the numbers of electrons to equal before we add them back together because we want them to cancel out. So we're going to multiply this whole thing times 3. And we're going to multiply this whole thing times 2. Do it and rewrite. Multiply everything in it by 2. Multiply everything in it by 3. All the coefficients should be multiplied in front of your reaction.
I don't have enough room in my notebook for adding this vertically.
Oh, what's that? Yeah, you know, but
I will.
quietly, please.
I'm in my free time notebook. I'm not even kind of open.
You multiply the entire equation, right?
Yep.
Just one side.
Both sides of both equations.
You can bring your brother. Go get some cat treats.
There's my first one.
Good for you. Wait.
It takes practice.
I'm just scared that almost like a tiny thing will go off into the charge and then there's a problem that we wrong.
Eight. No, it's wrong. It's H2.
All right, so that's what we should have before you add them back together. Next step is to add them all together. And cancel out what you have on both sides. Ooh.
Yeah, don't have to combine that.
Yup.
That's so much.
Wait, isn't that going to cancel with this? No. No, they said hello, that one's
The OHs cancel as well?
They will. Yep.
It looks like we have 60.
Not all of them. You will have some left over. Here's where I'm at before I cancel out my waters. I already canceled out my electrons. I've got 11 waters on the left and 10 on the right. So these are going away, and I'm going to be left with 1 water. Ooh, what else cancels out on both sides? OHs. I've got 6 on the left, leaves behind 2 on the right. So my overall reaction, once I rewrite everything, like that. All right, I'm gonna stop there and we'll talk voltaic cells on Monday. For the weekend,
Yeah.
let's talk about it.
Let's just like, let's stop you there.
Let's talk about it. If you come down to the practice section, just come down here with me. For Monday, I want 1A. I want 2A. And I want 2D.
So we don't have to have this done by
So
Saturday at 1:59?
1A, 2A, and 2D.
Is this due Monday?
For Monday, yes. For Monday, 1A, 2A, 2D. Okay? After that board, we added this together to get our final reaction, which is the one that's balanced. Okay, so pause it here if you need to. Have a great day.